Hi. Till now, we have studied about log variable, turn variable, and interested variable. And we have seen that there were some disadvantages in each of these mechanisms. Like in log variable, there was no mutual exclusion at all. And in turn variable, we saw that everything was perfect, but progress was not there. And in interested variable, there was deadlock as well as progress was not there. In order to achieve all the basic requirements of process synchronization, what Peterson did, he cleverly combined the concept of turn variable as well as interested variable. And he came up with a new solution which satisfied all the basic requirements of process synchronization, that is mutual exclusion as well as progress as well as bounded waiting, and also moreover deadlock was also not there. Okay, so today we will study about this Peterson's algorithm. Okay, here we will analyze the code, and we will and and for every for every condition we will see how these things are getting satisfied. Okay, so let's study about Peterson's solution. So here you see I have written the code for Peterson's solutions. So this code may be little bit different from the usual code that you may find in your books or in the internet, but don't worry, the concept is totally same. And moreover, it's this code is very simple to explain, and rather you will find it more interesting. You will enjoy this. Okay, so let me explain this. So here you see I have written hash define n2. N2 means what? Number of processes are 2. So just remember this important point is Peterson's algorithm is applicable for only two processes. Only two processes. Okay. And next thing is that hash define true is 1. Hash define false is 0. It means what? 1 is true and 0 means false. Okay, so int interested n is equal to false. So here you see the processes interested means what? As I've already told you in the previous lecture, interested means what? It indicates the interest of a process to enter inside the critical section. Okay, so here the interest of both the processes are initialized as false, like this. Here you see, here I am writing interest, and the process name is P0 and P1. P0, P1. So interest of P0 and interest of P1 are both initialized as false. So it means what? Now both the processes are not interested to enter inside the critical section. Just wait. Fine. And after that, you see there is a turn variable. Okay, there is a turn variable. So as I've already told you that both interest and turn variable will be used in this algorithm. So here you see this is an entry section code. Okay, from here to line number 5, you can see it's an entry section code, and after that here is a let me drop this. Here is a critical section, and after that there is an exit section. Okay, I have given the line number 1, 2, 3, 4 in order to make you understand in a simple manner. Okay, so you see what's written in the void entry, int. So here there is a parameter int process. Okay, so int process. So process basically means what? You see there are two processes, P0 and P1. If a CPU is assigned to P0, then P0 will be known as process. Okay. If CPU is assigned to P0, then P0 will be known as process and P1 will be known as others. Okay. So int other. So suppose if CPU is with process P0, then P1 is others. Okay, P1 is other, sorry. So let's see how P1 is other. Int other is equal to 1 minus process. So see how beautifully this code is written. Other is equal to 1 minus process. It means what? Here you see, rather than P0 or P1, I will use the process ID as 0 and 1. 0 means what? It indicates the process P0, and 1 means what? It will indicate process P1. Okay. So suppose CPU is with process P0, then other is equal to, you see, other is equal to 1 minus process. So 1 minus process. So what is the process now? P0, then other is equal to 1 minus 0. Here I am writing other is equal to 1 minus 0. Why 0? Because 1 minus process. So process is 0. P0 is the process. Then other is equal to 1. So it means what? Other is P1. Why? Because other is equal to 1 and 1 means P1. Okay. So, and the third line is interested of process is equal to true. So it indicates that process is interested to enter into the critical section. And now you see CPU is with process P0. So process P0 is interested to enter inside the critical section. That's why process P0 will execute line number 1, P0.1, then P0.2, line number 2, and after that P0.3. So in P0.3, interested of process is equal to true. It means what? Interested of 0 is equal to true. So interested of P0 is true. So now here I will write true. It indicates that process P0 is interested to enter inside the critical section. And also you please remember one thing, that if the interest is true, it means what? The process is interested to enter the critical section, and also if the process is inside the critical section, then also the interest variable of that particular process will be true. Okay. The interest variable will be true in two cases. The first case is that if a process is interested to enter inside the critical section, and the second case is if the process is already inside the critical section. Okay. So we have executed line number 3. Then let's execute line number 4. What's written in the line number 4? Turn is equal to process. It means what? It process P0's turn to enter inside the critical section. Therefore, turn is equal to process. What is process? 0. 0 means what? P0. So here I will write 0. Okay. If it would have been P1's turn, then here I would have written 1. Okay. Now, since P0 is interested to enter the critical section, so P0 will execute this while loop. In the while loop, you see what I have written. Interested other is equal to true, and turn is equal to process. Okay. So P0 will definitely try to break this while loop, and let's see whether P0 can succeed or not. So P0 has executed line number 4, and P0 is now executing line number 5. So here you see in the line number 5, this condition should be checked. Interested of other is equal to true. So it means what? P0 is checking whether other process is interested to enter inside the critical section. You see, in case of interest variable, what I told you, that if other process is interested, then I will not enter. I will only enter if other process is not interested. Then only I will enter. So that's why P0 is checking interest of other is equal to true, whether other process is interested. Other process means what? P1. Whether P1 is interested? No. P1 is not interested. So here false is written. So false is equal to true. It means what? It's a false condition. So the false is equal to true means what? It's totally a false condition. So here, while the first condition is false, and so here we have to check the second condition also. Turn is equal to process. So let's see whether turn is equal to process. So turn is equal to process. Yes, here since CPU is with process P0, so that's why P0 is the process. Okay, and P1 is the other. So turn is equal to process. So turn is equal to process. Yes, turn is equal to process. So this condition is true. Although this condition is true, but still we know that false and true is equal to false. So this is overall the while condition is false. Since the while condition is false, here you see at the end semicolon is there. So it means what, this while loop will be broken. And since this while loop will be broken, so P0 will successfully enter inside the critical section. Here you see P0 has entered inside the critical section. Okay. So now we will see whether mutual exclusion is there. So for that, we will try to enter P1 into the critical section when P0 is already present there. Okay. So let's see whether mutual exclusion is possible or not. So when P0 is inside the critical section, preemption happened and CPU is given to process P1. So now CPU is with process P1. So CPU is with process P1. So this time the process is P1 and other is P0. Okay, let's see how. So now P1 will execute line number 1. P1 will execute line number 2. So you see in line number 2 what is written? Other is equal to 1 minus process. So this time process is 1, process is P1. So other is equal to 1 minus process. It means what? 1 minus 1. So other is 0. It means what? Now P0 is the other process. Okay. Now P1 will execute line number 3. Okay. In line number 3, interest process is equal to true. So now interest process is equal to true. So now here you see interest of process. It means what? P1 will become true. So now it is true. Why? Because P1 wants to enter inside the critical section. Okay. So in line number 4, turn is equal to process. So now P1 will execute line number 4. Turn is equal to process. So here turn will become 1 because process is P1. So let's see whether P1 can enter inside the critical section or not. So P1 will execute this while loop. So let's check the condition inside the while loop. While interested other is equal to true. So whether other is interested. So now since CPU is with P1, so other is process P0. So whether P0 is interested, yes, interest of other is true. So true is equal to true. This condition is true. And also I have told you that if one process is already inside the critical section, then also the interest of that process will be true. Okay. P0 is already inside the critical section. So interest of P0 is already true. So here you see true is equal to true. So this condition is true and turn is equal to process and turn is equal to process. So here process is P1. So turn is equal to process. So you see both the conditions are true. Since both the conditions are true, so the while loop will not be broken. So here P1 is stuck in the while loop. Okay. So here you see that mutual exclusion is there. It's a clear case of mutual exclusion. Okay. And also moreover you can see that when P0 was not in when P1 was not interested to enter inside the critical section, then P0 could successfully enter inside the critical section. So there is a progress also, because if one process is not interested, then it is not stopping other process. So progress is there, but now still we can't say that progress is guaranteed, because we have to analyze different conditions. Okay. So you see here P1 is stuck in the while loop and P0 is already inside the critical section. So there is a mutual exclusion. So when P1 can enter inside the critical section, so for that P0 will have to come out from the critical section and we'll have to execute this line number 6, this exit code. Let's see. So suppose the task of P0 inside the critical section is over. Now P0 wants to come out from the critical section. So for that P0 will run this exit code, and for that P0 requires CPU. So now CPU is given to P0 again. So there is a preemption and now CPU is with P0. So this time process is P0 and other is P1. Okay. Now, let's see here. So, P0 will execute line number 6. Fine. In the line number 6, what's written? Interested of process is equal to false. So, since P0 has already completed its task, so it no more wants to enter inside the critical section. So, here you see P0 has made, so the interest of P0 is false this time. It means what? P0 doesn't want to enter inside the critical section. It has no interest. Okay. And since P0 has been made false, so this time P1 can enter. You see how. Now suppose again CPU is given to process P1. So P0 has come out from the critical section. Okay. So now CPU is given to process P1. Initially P1 was stuck in the while loop. Okay. Here you see P1 was stuck in the while loop. So let's see whether P1 can now enter inside the critical section or not. So again P1 will check the condition while interest of other is equal to true. Interest of other is true. No, interest of other is false. Okay. So it means what? This condition is false. And turn is equal to process. And turn is equal to, although turn is equal to process, but you see the previous condition interest of other is equal to true. This condition is false. So false and true is false. So this means what? While loop will be broken. And since while loop will be broken, so now P1 will enter inside the critical section. So here P1 will enter inside the critical section. Okay. So in this way, this code will run. Okay. It's simple. And here few things are to be noticed, and also we will analyze for different conditions. Okay. So here you see one thing, that the process which sets the turn value first, the process which sets the turn value first will enter the critical section first, and the process which sets the turn value last will have to wait. I mean to say that it will enter the critical section at last. You see how it happened here. When process P0 was trying to enter the critical section, so process P0 executed line number 1, 2, 3 and 4th. So process P0 executed this line number 4 first. Okay. Okay. Process P0 executed this line number 4 first. And after that, okay, okay, I will tell you about this later. So now let's analyze the different condition. Okay. Till now everything is fine. So let me rub this. Okay. So now you see how the processes can enter inside the critical section using Peterson solution. So here we have analyzed one condition when P0 was interested and P1 was not interested. Then in the critical section P0 could enter. And after that, when P1 was interested and P0 was not interested, then P1 could enter inside the critical section. We have seen here. Now, suppose you see if both the processes are interested at the same time. Just remember from the previous lecture, we saw that when both the processes was interested, when both the processes were interested at the same time, then what happened? Deadlock happened. Progress was getting violated. So let's see whether these problems will exist here. Let's see. Suppose both the process want to enter into the critical section. Okay. So initially both are initialized as false. So first suppose P0 will run. So CPU is with process P0. Fine. CPU is with process P0. So P0 will run line number 1. So now the process is P0 and other is P1. Okay. So P0 will execute line number 1. P0 will execute line number 1. Then P0 will execute line number 2. Then P0 will execute line number 3. So line number 3, interested of process is true. So now interest of P0 is true. So here I will write true. Okay. So after executing this line number 2, before P0 could execute this line number 4, suppose preemption happened here at this point, and the CPU is given to process P1. So you will see what will happen now. Now you see CPU is given to process P1. So since CPU is given to process P1, so now P1 is the process and other is P0. Okay. So P1 will execute line number 1. Here you see context switching happened. So now P1 will execute line number 1. P1 will execute line number 2. Okay. And now P1 will execute line number 3. So line number 3, interest state of process is equal to true. So now P1 is interested. So now it will become true. Interest of P1 is true. And P1 executed line number 4. P1 of 4. So here you see turn is equal to process. So turn will become what? P0 or P1? Obviously P1, because now process is P1 and other is P0. So now turn is 1. So P0 has executed line number 4. And now, so just remember, this time the value of turn is set by P1 first, because P0 has not yet set the value of turn. Because before P0 could set the value of turn, the context switching happened. Okay. So P1 access the turn variable first. Remember this point. Okay. Now, suppose after this line, again the preemption happened. Okay. And the CPU is given back to process P0. So here, CPU is given back to process P0. So here I am roughing this. So now, process is P0 and other is P1. Okay. So P0 executed up to line number 3. So now P0 will start from line number 4. So here P0 will execute line number 4. Okay. So line number 4 is what? Turn is equal to process. So now P0 will set the value of turn. So now turn will become 0. Okay. Turn will become 0. And after that, P0 wants to enter inside the critical section. For that, P0 will execute line number 5. Okay. So in line number 5, in the while loop, there is a condition interest of other is equal to true. Let's see. Now other is P1. So other is interested. Yes, P1 is interested. So this condition is true. And turn is equal to process. And turn is equal to process. Yes, turn is 0. Here the process is P0. So turn is 0. So turn is equal to process. So both these conditions are true. So it means what? While loop will not be broken. So here you see P0 got trapped in the while loop. Okay. P0 got trapped in the while loop. And also you remember one thing, that P1 was the first process to set the turn. After P1, P0 set the turn value. Okay. Here you see P1 first set. After that, P0 set. Okay. So why I am repeating this again and again, you will come to know after some time. So now P0 is trapped in the while loop. So now again context switching happened, and at this time CPU is given to process P1. So now CPU is with process P1. So process is P1 and other is P0 now this time. So P1 executed till line number 4. So now here you see P1 executed till line number 4. So now P1 will execute line number 5. So here I will write P1.5. So let's see whether P1 could enter inside the critical section. So interest of other is equal to true. So now other is P0. Since CPU is with P1, so now other is P0. So whether P0 is interested? Yes, P0 is interested. So first condition is true. And turn is equal to process. So what is the process? P1. Okay. So now turn is equal to process. Here you see, no, turn is not is equal to process. Okay. So here you see turn is equal to process. So but here you see this time process is 0, not 1. Okay. So this condition is false. this condition is false. So it means what? Since this condition is false, first condition is true and second condition is false. So true and false is equal to false. So it means what? While loop condition is false. So while loop will be broken. So while loop will be broken and P1 will enter inside the critical section. Okay. So here you see both the processes was interested to enter inside the critical section. But which process entered the critical section? P1. Why? Because P1 was the first process which accessed the turn variable. Okay. P1 set the turn variable first. And after P1, P0 set the turn variable. But since P1 set the turn variable before P0, so P1 could enter the critical section. So it means what? The process which sets the turn variable last, it will have to wait. So here P0 set the turn variable last. Okay. P0 set the turn variable last. So it means what? Before P0, since P0 set last, so before P0, some process might have set the turn value. So that's why here P0 will wait and P1 has got the entry inside the critical section. Fine. So here you see P1 has got the entry inside the critical section. P1. Why? Because P1 set the turn variable first. If P0 set turn variable first, then P0 could get the entry inside the critical section. So here you see the role of turn variable. So the entry inside the critical section. So turn variable will decide if both the processes want to are interested at the same time to enter inside the critical section, then turn variable will decide which process should enter inside the critical section. Okay. So here you can see that mutual exclusion is there. It's a clear case of mutual exclusion. Here I write. Let me rub this. Here mutual exclusion is there because both the process. Okay, let's analyze one more thing, that when P1 is in critical section, when P1 has entered the critical section, now suppose CPU is given back to process P0. So let's see whether now P0 could enter inside the critical section or not. As we know that P0 is stuck in the while loop, so let's see whether this while loop could be broken or not. So interest of other is equal to true. So since CPU is with process P0, so other is P1. So interest of other is equal to true. Obviously, it's a correct statement. And turn is equal to process. And you see turn is equal to process. So this condition is true. So while loop will not be broken for P0. So now P0 couldn't get the entry inside the critical section. Okay, it means what? When one process is present, the other process. One process is present in inside the critical section, then other process can't enter inside the critical section. Okay, so definitely mutual exclusion is there. Mutual exclusion is there. So now let's analyze another condition. Just let me rub this. Okay. Just wait. So here you see, I forgot to mention one thing about the deadlock. You see here. Let me explain again. So you see here, when process P0 was interested initially and process P1 was false. Okay. When CPU was with process P0 and process P0 was interested and process P1 was not interested. Okay. And after that, process P0 executed line number 3. Fine. So process P0 executed line number 3. After that, when preemption happened, so P1, so CPU was given to process P1. Then what happened? So P1 executed line number 1, line number 2, line number 3. In the line number 3, the interest rate of process became true. Okay. And after that, P1 set the value of turn as turn is equal to process. So now turn is equal to process. Okay. And after that, when P1 tried to execute this while loop, you see what happened. P1.5. When P1 tried to execute this while loop, now you see what happened here. So you can see here interest state of other is equal to true. Interested. So since CPU is with process P1, so other is P0. So interest of 0 is true. Obviously it's true. And turn is equal to process. And turn is equal to process means what? Turn is equal to process. And also this is true. Turn is equal to process. So it means what? Both the conditions are true. So turn is equal to process. Okay. So here you see now both the conditions are true. Interested of other is equal to true. If interested of other means what? P0 is interested. Yes, P0 is interested, and turn is equal to process. And turn is equal to process. Process is P1, turn is equal to process. So since both the conditions are true, so here it means what? True and true is equal to true. The while condition is true. So now while loop will not be broken. So P1 got trapped in the while loop. Okay. So at this time, suppose context switching happened. And now CPU is given to process P0. CPU is given to process P0. So process P0 executed till line number 3. And now process P0 will execute line number 4. Then you see what will happen. Process P0 will execute line number 4. Turn is equal to process. So now turn will become 0. Okay. And after that, process P0 will execute line number 5. You see what's written? Interested, other is equal to true. Other is interested. Yes, P1 is interested, and turn is equal to process. And turn is equal to process. Yes, turn is equal to process because P0 is the process and turn is equal to process. So it means what? This condition is also true. True and true is equal to true. It means what? Overall condition of while loop is true. So it means what? While loop will not be broken. And if while loop is not broken, then process P0 also got trapped in the while loop. So here you see, if we analyze this condition, then we can see that both the processes are trapped in the while loop. So is it a deadlock? It's like a deadlock. Both the processes are trapped in the while loop. So you will say that it's a deadlock. No. Here deadlock will not happen. Okay. Although it looks like a deadlock, but still this loop can be broken. You see how. Suppose at this point a context switching happened again, and now CPU is given to process P0. Okay. So now you see what will happen. Since CPU is with process P0, so now you see, so process is P0 and other no. Here the context switching happened and now CPU is given to process P1. Okay. So now let's see what will happen. Since the process CPU is given to process P1, so other is P0 and process is P1. Okay. So here you see what will happen. P1 was executing line number 5. Okay. Now you see what will happen. Here process this here since CPU is with process P1, so process is P1 and other is P0. Okay. So P1 is at this point context switch happened and P1 is executing this while loop. Let's see what will happen. Interest rate of other is equal to true. Other is what? P0. Yes, interest of other is true. P0 is still interested to enter inside the critical section. That's why P0 is waiting here. Okay. And turn is equal to process. So now turn is equal to process. Turn is equal to process. No, turn is 0, but the process is 1. So it means what? The second condition is false. Okay. First condition is true and second condition is false. So true and false is false. So it means what? The while loop, overall condition of while loop has become false and while loop will be broken. Since the while loop will be broken, so now this time P1 will enter inside the critical section. So you see here the beauty of this algorithm. You see, although here it was here it looked like a deadlock, but actually deadlock didn't happen. You just see how. You see here when P1 was the first process. Okay. P1 was the first process which set the turn variable. Okay. After P1, P0 set the turn variable. So it means what? P0 was the last process to set the turn variable. So I already told you the process which will set the turn variable last will have to wait, and the process which will set the turn variable first will enter inside the critical section first. Although both are interested to enter inside the critical section. Okay. So for this, so to stop this condition, since both are interested, so there is so in the interested variable lecture, what you saw, when both the processes were interested at the same time, then deadlock happened. So here also when both the processes are interested, then there is a chance of deadlock. So in order to stop the deadlock, we use turn variable. How? You see here, process P1 set the turn variable first, so process P1 could enter inside the critical section, and process P0 set the turn variable last, so process P0 had to wait inside the while loop. Wait till when P0 will come out from the critical section. After that, process P0 will enter inside the critical section. Okay. So here you see deadlock is not there. So let me write here. Deadlock is not there. Okay. So let's see whether progress and bounded waiting is there or not. So here we can also see that progress is also there, because you see when P0 initially I told you that when P0 was interested, okay, and P1 was not interested, then P0 could enter inside the critical section. P1 was not stopping P0 to enter inside the critical section, and also vice versa. When P1 was interested and P0 was not interested, then also P0 didn't stop P1 from entering inside the critical section. P1 could easily enter inside the critical section. Here uninterested process is not stopping the other interested process to enter inside the critical section. So definitely progress is there. And moreover, we have also seen one condition: when both the processes are interested, then also one process could enter inside the critical section. Unlike the case of interested variable, when both the processes were interested, then deadlock was there. But here you see, even when both the processes were interested, then one process could enter inside the critical section. Which process? The process which set the turn value first. Okay. So here we can see that progress is there. Progress is there. So mutual exclusion is there, progress is there, deadlock is not there. Till now everything is good. Till now everything is fine. So now let's check bounded waiting. So now we are going to check bounded waiting. So whether bounded waiting is there or not. So bounded waiting means what? If one process is waiting in the while loop, one process is trapped in the while loop, and other process is inside the critical section, it means what? The trapped process is waiting for the other process to come out from the critical section so that I will get the chance. But you see, sometimes what will happen, that when the process comes out from the critical section, and before the trapped process could enter inside the critical section, the other process again get the entry inside the critical section. So it means what? The bounded waiting gets violated. Okay, bounded waiting means what? Here each process will get the equal chance. So we will analyze here whether bounded waiting is there or not. So let's see. So suppose you see process P0 is inside the critical section. Okay, for the time being, suppose process P0 is inside the critical section and process P1 has got trapped in the while loop. Okay. So, let me rub this. So, since process P0 is inside the critical section, so the interest of process P0 will be true. As I already told you that the interest can be true in two cases. First is when the process is already inside the critical section, and the other is when the process is interested to enter inside the critical section. So since process P0 is already inside the critical section, so the interest of process P0 is true. And also since process P1 is trapped in the while loop, how process P1 got trapped in the while loop? Definitely it might have tried to enter the critical section, and when it will try to enter the critical section, when the interest of process P1 is also true. So here you see the interest of process P1 is true. Okay, and also you see that since P0 is inside the critical section, it means what? Process P0 has set the turn value first. That's why it could have entered inside the critical section. So process P0 set the turn value first. Okay, and P1 is waiting. It means what? Process P1 might have set the turn value last. That's why it is waiting. So last means what? After process P1 set that, after process P0 set the turn value, after that process P1 set the turn value. It means what? The latest value of the turn is 1. Okay, the latest value of turn is 1. So it means, so you see here the process P1 is trapped in the while loop, and process P0 is inside the critical section. So now the task of process P0 is over, suppose. Okay, so process P0 will come out from the critical section after executing this line number 6. So process P0 will execute this line number 6, and you see what's written: interested of process is equal to false. So interested of process is equal to false. Okay, so process P0 is out from the critical section. Okay, so now since process P0 is out from the critical section. Okay, so since process P0 has exited, so now according to bounded waiting, now process P1 should enter. Okay, but it can also be possible that before process P1 could enter inside the critical section, P0 again execute all this code, and P0 got the entry inside the critical section, and again process P1 will have to wait. So will it possible in this case Peterson solution? Let's see. So now process P0 entered exited the critical section, and suppose P0 again want to enter the critical section. Before P1 could enter inside the critical section, process P0 again want to enter inside the critical section. Let's see, is it possible or not? So now process P0 has again got the CPU. Okay, so process P0 will execute line number 1, process P0 will execute line number 2, process P0 will execute line number 3. Line number 3 means what? Interest of process is true. So again process P0 is interested. Okay, and now process P0 will execute this line number 4, P0.4. So it means what? Now process P0 will set the turn value as what? Turn is equal to process. It means what? Turn is equal to 0. Okay, now turn is equal to 0. Fine. So now let's see whether process P0 will enter inside the critical section or not. Now you just understand one thing: the turn is 0. Okay, and P0 had set the value of turn. It means what? P0 is the last process which set the turn value as 0. Before P0, the value of turn was 1. It means what? Before P0, some process, that is P1, had already set the turn value as 1. But after that, P0 modified the turn value as 0. It means what? P0 is the last process which set the turn value. Okay, so definitely since P0 is the last process which set the turn value, so definitely P0 will wait. Okay, let's see. So now P0 will execute line number 5. Fine. So let's see. Interested of other is true. Yes, P1 is interested. That's true. And turn is equal to process. And turn is equal to process. Turn is equal to process. Since CPU is with process P0 and turn is equal to 0, it means what? Turn is equal to process. So it means what? P0 got trapped in the while loop. P0 could not enter in the while loop again. Okay. So now see, now P1 can enter inside the while loop or not. So P1 will execute line number 5. Okay, you just assume that P1 has already executed 1, 2, 3, 4. Okay, now P1 will execute line number 5. Interested of other is equal to true. So let's see. So now P1 will execute line number 5. So now CPU is with P1. So now other is P0. So interest of other is true. Yes, interest of other is true. And turn is equal to process. So turn is equal to process. No. Turn is not 1, turn is 0, so turn is not is equal to process. It means what? The first condition is true and second condition is false. So true and false means what? False. So here overall condition of while loop is false. So it means what? While loop will be broken. So now P1 can enter inside the critical section. So here you see bounded waiting is also there. How? Because each process is getting equal chance. When process P1 was waiting to enter inside the critical section, okay, how process P1 was waiting? P1 was waiting for P0 to come out from the critical section, okay. And when process P1 came out from the critical section, P1 could get the entry inside the critical section. And also, you see, I of this, okay. So is it visible? Okay, I am writing here. So you see here what actually happened. Here P1 was waiting to enter inside the critical section, okay, and P0 was already present. So when P0 came out from the critical section, okay, then definitely P1 should enter. But here again what happened? P0 again tried to enter inside the critical section. But this time, the code of Peterson's algorithm is written in such a way that it didn't allow the process P0 to enter the critical section again. Okay. And this time P1 got the entry inside the critical section. So here both P0 and P1 are getting equal chance to enter inside the critical section. So here bounded waiting is there. So that's all about Peterson's algorithm. So I hope you got it. I tried my best to in order to make you understand this algorithm. So some 2 or 3 theoretical points are left. So let me rub this. I hope you got it. Okay. And even if you didn't understand, you just watch this video again. Definitely you will understand it. Okay. So let me rub this. So just remember these important points that in Peterson's solution, mutual exclusion is there, deadlock is there, deadlock is not there, progress is there, bounded waiting is there. So all the requirements of process synchronization is present here. And one thing that is still can't be made, that is busy waiting solution. So here busy waiting is not there. Okay. So in order to achieve busy waiting, we need semaphore concept. That will come later. So for the time being, just focus here. So the theoretical points are that it is a software solution. Software solution runs at user mode. Okay. Oh. Straight. Runs at user mode. It means what? It doesn't require the support of operating system. Okay. Second one is that two processes solution. Only two processes can be involved here. Okay. Only two processes. It is not applicable for multiple processes. That is a little bit disadvantage. Third point is that architectural neutrality. That is, it doesn't require the support of operating system. And the important points are that mutual exclusion is there, deadlock is not there, progress is there, bounded waiting is there, but busy waiting, this problem is yet to be solved. Okay, so in the semaphore concept, we will see how this bounded weighting problem can be solved. Okay, so that's all about Peterson's algorithm. So thank you.